Hello everyone, welcome back to Tuition Masters, and today we are here with another session for grade 9 CBSE Mathematics, that is one short revision for the chapter triangles. So students, in our today's session we are going to discuss about the congruence of triangles, criteria for congruence, the properties of triangle, inequality in a triangle, and some important questions, some subjective questions of this chapter. So students, this is a not live video. I couldn't come, but yes, it's a premiere for all of you, so you all can access it easily. If you have any doubts, always you can ask it in the comment section below. So students, let's see the congruence of triangles. What do we mean by congruence of triangles? So we know that in our previous standards in your 7th grade, 8th grade, you might have studied what are triangles, what is congruence, also everything you might have studied. I won't just repeat all those things again. We'll do some new points. Triangles, what is a triangle? Very simple. A triangle is nothing but a polygon. Correct? It's a polygon with how many sides? It is a polygon with 3 sides, isn't it? So that is what the definition of triangle is. How many angles it has? It has 3 angles. It has 3 sides. And what else? It has 3 vertices also, isn't it? So if I say this is my triangle, one side, two side, three side, for one vertex, two vertex, second vertex, I mean third, then first angle, second angle, third angle. So we have 3 angles, 3 sides, and 3 vertices. Now based on this, what is congruence now? Basically, two triangles are congruent if and only if their corresponding sides and corresponding angles are equal. Now, what happens to students when I talk about corresponding sides? Means whenever I'm taking congruency, I will be taking exactly two shapes. I mean, here we are talking about triangles. I'll take two triangles. Okay, let's say I have triangle PQR and I have triangle ABC, isn't it? Now what happens is, as we'll study ahead, we have few criteria. For example, we have ASA, we have SSS, we have RHS, and etc. We have congruence, right? Now based on this, what happens is, if you have PQ is equals to AB. If PQ is equals to AB. Okay, that is one criteria. Then say QR and BC. QR equals to BC. That they are equal. And PR equals to AC. Correct. The PR equals to AC. So what I can prove, this is basically SSS congruence criterion, right? So what happens, you can say that accordingly triangle PQR will be equals to triangle ABC. Now will it be equals to? It will be congruent to. Means what is congruence? Basically, congruence of triangle means that when one triangle can be made to superimpose on the other, so as it cover it exactly, then the true angles are congruent. So say suppose I am taking one, this is one triangle, okay, one triangle. Now I am taking another triangle, I cut it and put it on this. Now if it is superimposing exactly, so that is what congruence basically means. Okay. Now, what is congruence correspondence? How do you write it? Correct. So, correspondence between the vertices, a correspondence between the vertices of triangle ABC and triangle DEF, in which the corresponding angles are congruent, is called a congruence correspondence. Means basically the correspondence can be of two things. Either it can be of the angles, either it can be of the sides. Only of these three, the only these two congruence can be there, the corresponding parts, like two angles one side, or two sides one angle, or only three sides. That way we find the congruence between two triangles. Now if I say two triangles ABC and PQR are congruent under correspondence, A is to P, B is to Q, C is to R. That means if I have a triangle, again we'll take the same triangles P, Q, R and A, B, C. Now what happens, first we have is A is corresponding to B. This vertex A is corresponding to this P. Okay, if I put A and B on each together, it will superimpose. Now B is corresponding to Q, B is corresponding to Q, and similarly C is corresponding to R. This arrow, a line with two arrows, that is known as a correspondence sign. So what I can say, with this I can say that triangle ABC and triangle PQR, what are they? I will not say they are equal, I will say they are congruent. What is the sign of congruence? The sign of congruence is equals to and like this approximate mark on the box. That is the sign of congruency. Okay. So this is the basic idea about what is congruence. Now the criteria for congruence. How do I say what is the criteria for congruence? So basically there are criteria. Like I can't take any triangles. I will take two angles. I'll take two sides. I'll take two more sides. I can't do that way, right? I will have to follow some criteria for that. So with respect to that, we have few criteria. First one is the SSS, congruence rule. What does this SSS stand for? It stands for the side. When we talk about SSS rule, we are talking only about the sides. We are going to refer to the sides of the shape. I mean, not shape, triangle. Now, what is the definition? And I'll explain you by figure also. Definition says that if three sides of one triangle are equal to three sides of the other triangle, then the two triangles are congruent. Very simple. If all the three sides of triangle A is equal to triangle B, it is equal, they are congruent by which rule? By SSS congruence criterion, isn't it? Now see here. Let's say this figure. What we have, AB is 5 unit, PQ is 5 unit. This means AB equals to PQ. AB equals to PQ. Okay. Next, BC is 4 units and QR is also 4 units. So BC equals to QR. Both of them are 4 units. Now, AC is 3 unit, PR is also 3 units. So what I can say? I can write here AC equals to PR because both of them are 3 units. Now what I can say, all the three sides are equal of one triangle and the other. So with this, with respect to this, what will I say? I will say that triangle ABC is congruent to triangle PQR. Based on what? Based on the SSS rule, congruence criteria or rule. That is how you prove it. Okay, how you have to prove it? You have to write which all sides or angles are equal and then you will write it they are congruent. Okay, so this was SSS. Next comes SAS. SAS means side. There will be a side, there will be an angle, and again there will be a side. Now what can you understand from this? Side, angle, side, it doesn't mean any side and any angle. No. What is actually the meaning of SAS is, if I have two sides and the angle should be in between those two sides. Okay, the included angle of one triangle, it should be equal to the two sides and the angle between them of the other triangle also. Then only the triangles will be congruent based on the SAS criterion. How? I'll explain you. Now see, again we have this figure. Now we have AB, ABC, triangle ABC and triangle PQR. Now see this. What I'm taking AB. AB, it is equals to PQ. AB equals to PQ. They both are equal. Now I'm taking another side BC. I'm taking BC, that is equals to which side? It's equal to QR. Isn't it? It's equals to QR. Now I need minimum three things. Now what is the next thing? Do I have any side ACPR? There is no relation given. So I have an angle here. That is angle ABC. It is given equals to angle PQR. Now what is it? I can't take any angle, students. Remember that. If I'm taking these two sides, so this will be my included angle. Okay. And for example, if I take these two sides, if I take AC and BC, so then this will be ACB will be the included angle. Okay, that is how you prove SAS. Sorry. So what happens now? We have two sides and I have taken an included angle. Now what can I infer? Again, I will say that triangle ABC is equals to, no, is congruent to triangle PQR. By which rule? By SAS congruency criterion. Very good. So see this. You have to take the corresponding side. Okay, you have to take the two sides. Any two sides you can take. That's not mandatory. Any two sides. But the angle should be between. Okay, angle should be between them. Similarly, now we have ASA. Now ASA, previous one was SAS. ASA means angle, side, angle. Now what I was telling, see, previously when I said SAS, so two sides included angle. So when I say ASA means two angles and included side. So if two angles and the included side of one triangle, they are equal to the two angles and the included side of the other triangle, then two triangles are congruent. Now what you mean by this? You can take any two angles of a triangle. Okay, now if it is given, now what you have to do, if you take any two angles, so the side between them, I mean the side which is included in them, the in between those two angles, that side you will take. Okay, now let's see, again we have the triangles with us, triangle ABC and PQ. Now here see this, we have ABC. So we have angle ABC, that is equals to what? It is equals to angle PQR. It is equals to angle PQR. Similarly, we have now another angle we don't have any side. We have just one side. Another angle is ACB. This and this. Correct? So angle ACB, that is equals to angle what? Angle PRQ. PRQ. Now between them which side is present? We have BC in triangle ABC and we have QR in triangle PQR. The in between, the included side. So what will I say? I will say the side BC is equals to side QR. Now again we got this. So again we will say the same thing. Triangle ABC is congruent to triangle PQR. Now this time by which rule? This time by ASA rule, that is the angle side angle rule. Now similarly we have AAS also. Now what is the difference between AAS and ASA? AAS means angle side. That means if I have two angles and any one side of one triangle, then they will be equal to the two angles and the corresponding side of the other triangle. And what will happen? Two triangles will be congruent. So this means that this time in AAS, I can take any side. I can take any side here. Okay. I can take any side, but that side should be in the other triangle also. Okay. Whereas in ASA, I can take only the between one, only the specific one I can say. Let me explain you with an example. Here again. Now what we have? We have angle ABC, that is 40 degree, equals to angle PQR. It is equals to angle PQR. Now similarly, I have this also ACB, angle ACB, that is 80 degree, it is equals to PRQ. Angle, sorry, 1 minute. It is equals to angle PRQ, isn't it? PRQ. Now, am I taking this side? Am I taking this side in between them? No. I can take any random side. Any random side. So I'm taking AC and PR. Now it's not that you take AC here, you take PQ here, that will work. No. You have to, if you're taking AC here, so you have to take the same side, means PR there. So that is what it is. So AC is equals to PR. That is what we say as CPCT. CPCT, corresponding parts of congruent triangles. So you have to see the naming and everything very carefully. So what do I get from here? I get from here that triangle ABC equals to congruent to, sorry, a triangle PQR. Now see this. Can I write triangle ACB is congruent to PQR? Why is it wrong? See the students. ABC means I'm taking B here as 40. PQR, so angle Q is also 40. That is important. So B, Q, they are equals. I have to take them in middle. Now A, there is no relation, but I have R and C. So R and C are equal. So that is what CPCT is. You have to write the triangle name very carefully. You can't write any random name of a triangle, because I can write CAB also, BCA also, ABC also, BAC also, anything I can write for one triangle. But you have to write it as per given angles and as per given sides. Next rule is RHS rule. RHS rule is only, it is exclusive content, you can say. Okay, it is exclusively for right triangles. Right triangles means right angled triangles. Okay, it is for right angled triangles. That is the RHS rule. Now, what is RHS here? Right hand side? No, you're wrong. It's not right hand side. Uh, it is the RHS, hypotenuse and side, and R is the right angle. Now, if two right angles, I have to take two right angles here. For RHS, two right angles. Now, hypotenuse and one side of a triangle are equal to the hypotenuse and one side of the other triangle, then the two triangles are congruent. Why are they telling me only hypotenuse and side? Because R is nothing but right angle, and right angle is always 90 degree. It won't be 17 somewhere, 19 somewhere, no, right? It will always be 90 degree. So that is why we are not mentioning it. We are just telling about hypotenuse and side, they should be equal. Now come on, let's understand with this example. Now in this triangle ABC and PQR, what we have is, we have AC as the hypotenuse. This is my hypotenuse. This is my other one is, this is my side, and this is my right angle, isn't it? So what I'm doing here is AC equals to PR. That is what my hypotenuse is, isn't it? That is my hypotenuse. Now, next one is CB. CB is equals to RQ. Correct? That is my other corresponding side. And what else I have to write? You have to write another thing. You have to mention the right angle also, because that's important. Then angle ABC is equals to angle PQR. That is all equals to 90 degree, because it's a 90 degree angles, isn't it? So what do I say again? Again I will say that triangle ABC is congruent to triangle PQR. Now by which rule? By the RHS rule. Now you can say that, ma'am, we can even take ASA also, right? Or AAS you can take, because I'm taking one angle and one angle and two sides. That's not AAS. That's basically this, there is only one angle and two sides. So can I take SAS? No. SAS also means that it should be between. So it's not between. And whenever I have a right angle triangle, I will always use RHS only. No other rules are required. Okay. So we, how many rules we studied? We studied SSS, the three sides, SAS, side, included angle and side, ASA, that is angle and side between them. Then AAS means two angles and any side. RHS, which is a right angle, hypotenuse and the side, all only for right angled triangles. Very good, students. Next we are some properties of triangle. Now this basically a studying of isosceles triangle, some properties for isosceles triangles. Now what is an isosceles triangle? We know that there are three types of triangles based on sides. We have isosceles, we have scalene, we have equilateral. Scalene means all the three sides are different. Isosceles means two sides are equal, one is indifferent, and equilateral means all the angles and sides are equal, isn't it? Now, isosceles triangle, as I said, is a triangle where two sides are equal. Two sides equal, I have a isosceles triangle. So here you see two angles and two sides are equal in isosceles triangle. Now based on that, I have few theorems. I mean not few, I'll say in names, only two theorems. Theorem number one says that angles opposite to the equal sides of a triangle are equal. Now what I'm trying to say here is that, see, now angles opposite to the equal sides of a triangle are equal. Now what I'm telling is, what I have to take, I'm having opposite to equal sides. What are the equal sides? Let's in this picture xy and xz are my equals. Okay, they are equal sides of a triangle. Okay, so the angles which will be opposite to them, angles which will be opposite to them will also be equal. All the students, so when I say this angle and this angle, they are opposite, so they both will be equal to each other. So whenever I have angles which are opposite to the equal sides, I have equal sides, angles which are opposite to them, they will also be automatically equal. That is what our theorem 1 says. Theorem 2 says that the sides opposite to equal angles of a triangle are equal. Now this is again the converse. This is the converse of the first one. Okay, this is the converse of theorem number 1. If I have two equal sides, I mean equal angles, here I have 50 degree, 50 degree. These are opposite. Okay, I equal angles. Okay, what is the opposite side? AD. So AD will be equal. Alright, so that is what the meaning is. So sorry, not AD. Sorry, not AD. AD is the median here. AB and AC, they will be equal as they are the opposite sides. Is okay. So this is the basic theorem. Now we are going towards the inequality in triangles. Now what do we mean by inequality? First of all, inequality means that when two quantities are not equal. Very simple, right? Equality means my quantities are equal. Inequality means two quantities are not equal. Means there will be some, inequality or some differences. They won't be equal. One of the two may be greater than or less than the other. So another property of an inequality to be known as inequality is that one of the two quantities will be greater than or less than the other one. So based on this, again we have four theorems. Now theorem number 3. Why theorem 3? We did theorem 1 and 2 of the in the previous one, right? Of isosceles triangle. Now theorem number 3. Theorem number 3 says that if two sides of a triangle are unequal, if two sides of a triangle are unequal, then the longer side has greater angle opposite to it. Okay, now see here. I'll explain you, listen to me carefully. Just keep an eye on this figure and what I'm writing. See, what I'm telling is if two sides of a triangle are unequal. Now in this triangle, I'll find two unequal sides. Let's say I'm taking AC and CB. So I'm telling AC is not equals to CB. Okay, unequal sides I have. Now the longer side has greater angle opposite to it. That means that longer side is what? Longer side is nothing but AB. AB is the longest side. AB is my longest side, right? Now, which is the angle opposite to AB? Angle opposite to AB is angle ACB, correct? So, angle ACB is nothing but the largest angle. It will be the largest or the greatest angle. Why? Because it is opposite to the longest side. So when will this be applicable? It will be applicable only when you have two unequal sides. So when I have two unequal sides, so that time the longer side, the opposite to that longer side, the angle which is there, that will be the greatest angle. Okay. Now, similarly, we have theorem 4, which is nothing but the converse, the vice versa of theorem 3. Now, in a triangle, if the greater angle, whatever angle is greater, the side which is opposite to it, obviously will be the longest side. Now, see this. In this case, in this scenario, what we have is we have AB. AB is the, I'm sorry, not AB, ABC. It is the longest side. Okay, sorry, longest angle, largest angle. So I'm writing here angle ABC, that is my largest angle. Okay, that's my largest angle. Now which is opposite to AB? Sorry, ABC, which is opposite or which is opposite side to angle ABC? That is side AC. So AC becomes my longest side. Why does it become the longest side? Because whenever I have a greatest angle in a triangle, obviously there will be a greatest angle. So that greatest angle, the side which is opposite to that greatest angle will be the longest side, and the vice versa is theorem 3. Now theorem number 5 says that sum of any two sides of a triangle is greater than the third side. Very easy. I'm quickly going to explain you in 1 minute. See this. If I take any two sides, xy, xz. Now xy plus xz. That should be what? It should be greater than yz. Simple. Very simple. If I take two sides xy xz, so that will be greater than yz. Simple. If you take any two sides, if it is a true, if it's a real triangle, so if you take any two sides, that should be greater than the third side. Super easy, right? Let's take yz and xz. Now if I say yz plus xz, what should be the condition? It should be greater than what? Yz is done, x is done, so it should be greater than xy. Similarly, if I take xz and yz, xz, no, that's one. I take xy and yz. If I take xy plus yz, that should be greater than what? Xy, yz, so that should be greater than xz. So this is what the three things would be there. Alright. The last theorem is, of all the line segments that can be drawn to a given line from a point not lying on it, the perpendicular line is the shortest. What does this mean? Understand clearly. Now, of all the line segments that can be drawn to a given line. Okay, if I have a given line, I can draw line segments, isn't it? So from a point which is not lying on it, the perpendicular line segment is the shortest. So whenever I have a line segment, if I have a point constructed on it, so the perpendicular line means that which will make a 90 degree, a 90-degree angle, a right angle which it will make. So that will be the shortest one. That is theorem 6. So super easy, right? This chapter only has 6 theorem. We studied all of them, and all of them are super easy, isn't it? So if it is super easy, you understood everything. So now let's move towards some important questions. I'll be showing you some important questions. As this is a premiere, what you can do, if you want to try it on your own, you can pause the premiere, and you can solve it on yourself, or you can solve it along with me, and I'll be showing it to you. Now see this. In a triangle ABC, if AD is the perpendicular bisector of BC, then write the relation between AB AC. Now see this. I'll give you very, basic hint you should always do. Whenever you don't have any figure, but it's a figure based question, what you do is draw the figure. So what I'm going to do here is I'm going to draw the figure. Just draw it roughly. Okay, they didn't ask you to do it very perfectly, right? So you can do it roughly, not a problem. Now I'm drawing here. Okay, I'm drawing here. This is my triangle ABC. It's written as ABC, right? So I'm drawing it. This is ABC. Now what else is given? If AD is the perpendicular bisector of BC, so means I will draw a perpendicular bisector to BC. So this I'll draw straight line. It will bisect at 90 degree. This is my AD. Okay. Now what I have, follow the steps how I'm writing it. That's how you have to write an exam. So what you will do is that what is given to us. We will write that BD, this line segment BD will be equals to what? It will be equal to DC, right? Why will it be equals to DC? Because the AD is bisecting exactly in the middle. So that is why BC will be divided into BD and DC. So both of the parts will be equal to each other. So BD and DC are equal. Now let's say in triangle ABD and triangle ACD. We have two triangles in it, right? ABD, this one, and ACD, this one. I'm taking those two triangles. Now what I'm going to do is that I will see I'll use my congruence criterions here. Now in ABD and ACD, what things are equal? First thing is that AD is equal. AD equals to ADY, because that is my median. It is in the middle, right? It's my median here. Correct, that's in the middle, so it is common to both of them. It is equal, right? Now BD and DC, BD equals to DC. We solved here, it is given to us. We already solved here how it is provided. BD, DC, they both are also equal. And nextly, angle. Which angles are equal? Angle ADB, angle ADB is equals to angle ADC. Why are they equal? Because both of them are 90 degrees, right? See here, This is 90, this is 90, both of them are 90. Now what did I see here? I got here a side and an angle. So what does it mean? Which side, which angle I'm taking? It is nothing but my SAS criterion. So I have AD, I took BD, BC and the included angle. So this is what my SAS criteria is. So how will I write it at the end? I will write that therefore triangle ABD is congruent to triangle ACD. Now you will ask me, ma'am, this question was for writing the relation between AB and AC. Why did we prove this? Why did we find out the congruency? Because students, with the help of this congruency only we will be able to find the relation. Now AB, AC, they are equal. AB equals to AC. How? Because if you see, as I said, it is as per CPCT. It is as per CPCT. CPCT means corresponding parts of a congruent triangle. So AB, AC, they both are together, so they will be equal. BD, CD, they both are corresponding, so they will be equal. So similar relation between AB and AC are that they are equal. Why? Because it is in the corresponding side. So here is your solution. You can make a note of it. Next question. Now in this question we have the figure given to us. We have that in triangle ABC, AD is a perpendicular bisector of BCC. Figure is given, time is saved. Show that triangle ABC, this whole triangle is an isosceles triangle where AB and AC are the equal sides. Now how do I prove it? Now let's take again how many triangles we have. We have two triangles. So we are going to use them and we are going to do the congruency. So in triangle ABD and triangle ACD, these are my two triangles. I'm going to use them. What we have is things which are equal. Now we will take, now we can see DB equals to DC, DB or BD you can say, and DC, they both are equal. Why? Because AD is the median, so it is dividing into two equal line segments. So BD DC will be equal, right? It is given to us in the figure. It is given, isn't it? Second part, which angle? Angle ADB is equals to which angle? It's equals to angle ADC. Why? Because they both are 90 degrees. You can see here it properly clear it. Both of them are 90 degrees. Super easy. Now what thing else is equal? Which side is equal now? Any side is equal? Yes. AD. AD is equals to AD, right? Why? Because it's the common side. It's the median. It is common in both of them, so it is equal. So now again I use which criterion? I used my SAS criterion again. I used SAS. Now by SAS congruence, what do we get here? We will say that triangle ABD is congruent to triangle ACD, isn't it? It is congruent to triangle ACD. Now what they said, AB equals to BC, so AB AC, so AB equals to AC. Why? Again as per CPCT, corresponding parts of a congruent triangle. So that's why, hence we proved that triangle ABC is equals to an isosceles triangle. Super easy question. Now let's move towards the next question. This is your solution. Next question is, in the given figure it is given that AB equals to FE, AB FE are equal, BC equals to ED or DE, AB is perpendicular bisector to BD and FE is perpendicular bisector to EC. Alright, we have to prove that triangle ABD and FEC, these two triangles, this triangle, they both are congruent to each other. Now students, look at the figures carefully. Alright, this figure is the main thing, nothing else is important. Now let's see. Now first one, what we will see, we will take the things which are common, things which are equal to each other. We are going to take them. Okay, now first thing, I have that BC and ED are equal, right? BC equals to ED, that is given to me. It is given here, correct? BC and ED, it is equal. It is given to me. Now BC plus CD. If this I take this BC and CD means it will become the whole side BD. Correct. So if I add CD on both sides, if I do BC plus CD equals to ED plus CD. What I'm doing, I'm adding CD on both the sides because CD is the common thing, right? It's even there in EC, it's even there in BD. So I'm taking it common. Okay. So what do I get from this? I get from this that BD is equals to EC. Why BD equals to EC? See this. You see here BD. This was BD. This is EC. So the CD was common. I added to them, so I got this. So let's write it that this is my one property. I mean first equation. Now let's take the two triangles now. Now let's say in triangle ABD and triangle FEC. Triangle ABD and FEC. What things are equal? What things common? Let's see. We see is that AB equals to FE. That is given to me. In my question, it's given AB, FE are equal. Now, angle ABD. Angle ABD. See here in the figure you can look. Angle ABD is equals to angle FEC. Why? Because both of them are 90 degrees. So they are right angles, right? Here you can see. Okay, I'll change the C. 90 90. So they both are equal. What else now? Now we have that AB is perpendicular to BD, FE is perpendicular to CD. That's also given in our question, sorry, EC. Now what do we get? So by this we can say that BD is equals to EC. We solved it in the first part. BD equals to EC, we solved it. Now what do we get? Which criteria is it? Again the same criteria. It is my SAS criteria. So with that, what do I prove here? With that, I will write here that yes, by SAS criteria, I prove that angle ABD is congruent to triangle FEC by which criteria? SAS criterion. So super easy question. Here see, I have given you the solution. Now let's move towards the last question of the day, students. So yes, it's a little bit lengthy question, not very lengthy, also little bit lengthy. Now see. Question says BE and CF are two equal altitudes of a triangle ABC. Okay, I'm going to draw the figure side by side. I'm not going to wait. See this. I have a triangle. Okay, I have a triangle like this. I'll draw. I have a triangle and it's a little bit rough. Just manage. So it is ABC. Okay, this is my triangle ABC. What I have are I have two altitudes BE and CF. These are my two altitudes. Now using RHS congruence rule, I have to prove that this whole triangle ABC is an isosceles triangle. Now how do I do that? See here. Okay, can you see we are getting triangles in this now? There are so many triangles we are getting here, right? So we will go side by side. Now see here. First thing what I'll prove is that I'll take the triangle BEC, okay, and triangle CFB. BEC, this one, and CFB. Okay, this one. These two I'm going to take. Now what I'm going to do here is that I'm going to take the things which are common. Now what things will be common here? Think about it. Now what things will be common? First one, angle BEC. Angle BEC is equals to angle CFB. Right? CFB, this thing and this thing, they both are equal. Why are they equal? Because they all both are 90 degrees. Super easy. Next, BC is equals to BC. Why? That is my common side. Correct? That is my common side. And BE is equals to CF. Okay, it is given to me. BE and CF, they are the altitude, so they will be equal to each other, right? Now what do I get? This is done. Now I will take which? I'll take my RHS congruency criterion now. So by RHS, what can I say? I can say that triangle BEC is equals to, sorry, not equals to, is congruent to triangle CFB, right? If it is equal, if I take CPCT, what will I get? If I take CPCT, I will get EC is equals to FB. EC, FB are equal as per CPCT, right? EC and FB, these two sides are equal. So I got which part? I got this part I got and this part I got. But I need AF and AE also, right? How will I find that out? Now let's take another one. Let's take another triangle. Now I'm going to take triangle AEB, triangle AEB plus, and sorry, not plus, and triangle AFC. These two triangles. Now if I take these two triangles, what do I get? I can see that angle A. My angle A is equals to angle A, right? It is the common one. Next, the right angle. Right angle, what are the right angles? Angle AEB. Angle AEB is equals to angle AFC. Why? Because both of them are 90 degrees. AEB, this one, and AFC, this one. These two are 90 degrees equal. So what do I get here? Again, now by which criteria I'm getting it? I have two angles on one side. Correct, two angles on one side. Okay, sorry, I didn't take one more side. I'll take one more, that is EB equals to FC. EB, where is EB? Yeah, this one, and FC. These two are also equal. We found it in the previous question, isn't it? Now, let's come to the next slide. And now, what can we say by AAS? By AAS criteria, AAS, angle side angles criteria, what can I say? That triangle AEB will be congruent to triangle AFC also. Now, which were my sides remaining? I had AF, I had to take AF and AE. These two sides were remaining. So let's say AF and AE. So side AF is equals to AE. Why? Again, by CPCT, they both will be equal. So I got my both sides. Both sides are clear now. So if I add this one, this is, let's say, part number 2, and this one, EC and FB, this is my part number 1. The equation 1. So if I add both of them, what will I get? EC plus AE is equals to FB plus AF. This is what I'll get by adding them, right? I added these two things. So what will I get? AC plus AE. AC plus AE. What is that? Sorry, EC plus AE. So here if you see, AEC, this is my EC plus AE. That gives me AC. That gives me what? AC. And that is equal to FB plus AF. FB, FB plus AF. That is what? My angle, sorry, side AB. So two sides are equal. So what do I say by this? I will say that hence we have proved, triangle ABC is isosceles triangle. Super easy question. Here is a full solution. Again, the same thing which I explained, and nothing you can express there. Okay. So yes, students, thank you so much for watching this video. I hope it was very informative, and it was a bit lengthy, but yes, we completed the full chapter along with some important questions also. So thank you so much again for watching this live session. It was not live, it was a premiere, so no worries. You can write your doubts in the comment section. Don't forget to like this video and even share it with your friends, and join our live classes to score awesome marks in your exam. I'll be seeing you soon in the next videos. Till then, take care everyone and goodbye.